In this video, I'm going to talk about how we deal with multiple covariates in a linear regression and how we understand the coefficients and how they're fit in R. So I'm going to use this farm data as an example, and in this we have a numeric outcome, which is yield. So that is the yield of beets in pounds per acre. Then we have some covariates here. So our predictors are going to be seed types. So we have seed A, B, and C. We have a numeric predictor, which is fertilizer, how much fertilizer is added in pounds per acre. And there are 3 different farms that this experiment was conducted at. I want to remind everybody that an indicator is this little I that I have, and if it's the indicator for seed B, so if seed type is seed B, then it's going to be a 1, and if it's not, it's going to be a 0. So we're going to first start by looking at this linear regression, where I'm only going to put in the seed type and the fertilizer. I'm going to ignore the farm for now, and then the outcome is yield. You'll notice that we don't have a covariate for A in the model. That's because seed A is the baseline. Like if we put another term in for seed A and we kept the intercept, then we would have too many columns, I guess. What am I trying to say? We would have columns that add up to the intercept, and our matrix wouldn't be invertible. So we wouldn't be able to fit the model. So seed A is the baseline that we're comparing the other ones to. So first, let's talk about the meaning of beta naught in this. So beta naught, if we manage to make all the other things go away, right, we would be looking at seed A, and our fertilizer would be 0. So it's going to be the average yield for seed A when the fertilizer is 0. I can also say what happens if I set my seed as seed B. So I set my seed as seed B, and you can see here that the indicator for seed C, that guy goes away. It's a 0. And the indicator for seed B is a 1. And then I'm left with these guys. I can recollect the betas, and then I end up with an intercept. So if we have seed B, my intercept is beta naught plus beta 2, and my slope is still the same. So the way to look at this is that beta naught plus beta 2 is going to be the average yield for seed B when the fertilizer is 0. So that's the intercept for seed B. If I look at beta 2 by itself, it's the additional expected yield comparing fields with seed B to seed A. So it's how much the intercept, or how much anything, because the fertilizer effect is the same between them, how much it changes if you go from seed A to seed B. Right? It's this little gap right here. We could see that if seed A and seed B are the same, if there's no difference between them, then that beta 2 is going to be 0. So if you want to see if there's a difference between seed A and seed B, you would test whether beta 2 is 0. All right, so I've written here how the equations look for seed A, seed B, and seed C. You'll notice that beta 1 is the same for all of them with this fertilizer thing. So we have to kind of think about what it means in terms of all of the models combined. So to get beta 1 alone, you just need to have the same seed type, and then you have to make the fertilizer 1 unit, right? So Beta 1 is the expected increase in yield, so it's our slope, it's always our slope, for each additional 1 pound of fertilizer per acre when comparing plots with the same seed type. Notice that I am specifying that it's only comparing plots with the same seed type. When I go to fit this model in R, all I do to add another covariate is just put a plus sign. You can look and you can see that the estimates for the betas, so those should be like, that beta should have a little hat on it. I don't know if I put a little hat on it. Oh, I did put a hat on it. There you go. And those are the estimates for my betas. You can see that even though seed type has 3 levels, I just put in seed type, and then it will tell me what the levels are in the coefficients output. So like seed type, and then it says seed B. So there's my coefficients. Oh, those are their estimators. So here is a plot of this and what it looks like. These are the estimated regression lines for this model. You can see that beta 3, the seed C effect, is negative. So seed C is actually lower than my baseline seed, seed A. If I wanted to do something like estimate the expected yield when the fertilizer is 2 pounds and seed B is used, all I have to do is plug in the right covariates. So my fertilizer is 2 pounds per acre, and seed B, so the seed C part goes away. I plug in my estimators and I get my estimate. All right, now we're gonna look at a different thing. In this one, I have 2 continuous, or rather numeric, I guess, predictors. So I've added temperature, which is another numeric predictor, to my model. And I'm going to fit this model, which has fertilizer and temperature. So when I have 2 numeric predictors, I got to make both of those 0 if I want to interpret well, this one's a gamma, the gamma naught, so the intercept term. It's the average yield when the fertilizer is 0 and the temperature is 0. Now, when I go to interpret gamma 1, I'm going to have to think about how to get that like isolated. So to get it isolated, I would need temperature to be the same between the 2 equations that differ by 1 unit. So gamma 1 is the expected difference in yield for each additional pound per acre fertilizer. So that part's normal, right? It's just regularly interpreting a slope. And then I say, when comparing plots at the same temperature. So we're having to hold temperature constant, and then we're changing the fertilizer when we talk about gamma 1. All right, made it more complicated. Now I put the fertilizer, the seed B, the seed C, so I put the seed type, the fertilizer, the farm, and the temperature all in the same model, just so you can see how it would look. If I want to look at the baseline now, because I have 2 categorical covariates, the baseline farm is farm 1, the baseline seed is seed A. So I have to take that into account. Beta naught, the intercept, is now the expected yield for seed A at farm 1 when the temperature and fertilizer are both 0. Beta 1, the fertilizer effect, again, I have to make sure I'm holding all the other stuff constant. It's the expected increase in yield for each additional pound per acre fertilizer for plots with the same seed type on the same farm at the same temperature. So basically we need to hold all the other covariates constant and then talk about what the fertilizer is. Here's another possible way to write about beta 1. I just wanted to give you another option. So the idea is that we're comparing 2 different sets of plots, right? Plots that differ by 1 pound fertilizer, but have the same seed type on the same farm at the same temperature. Oh, one complicated thing that I want to go back and talk about really quick about this model where I have two numeric covariates. If I was to try to graph this, it would be a little difficult. Theoretically, it would be kind of in three-dimensional space, right? Fertilizer and temperature would be on the x and the y-axis, and then the yield would be on the z-axis. So plotting it could be a little challenging. This isn't necessarily something that would be easy to visualize. Just a side note, all the other things we talked about so far have been pretty straightforward to like show in a plot. This one is not so straightforward. All right, back to this guy. Again, this one would not be easy to show a picture of. You could do it by slicing the data up somehow and then like using color or size of the points to show that third dimension, but it's not going to be easy. So let's see what beta 5 would mean. So that is the indicator for farm 3. Again, that's going to be like the additive effect for farm 3. But our baseline, remember, is seed A and farm 1. So that's what that beta 5 is comparing to. So it's the expected difference in yield for plots on farm 3 compared with farm 1 that have the same seed type, right? Because if I have the same seed type, then those things would go away. Fertilizer added and temperature. So just to see if you can interpret stuff and how well it goes, I put a little activity together. To get the answers for this, you can check the website. I'm going to do the first one for you. So the idea of this is that I've written down for each seed, for each farm, what the expected yield would be. And then we need to try to figure out what these alphas are. So what are these parameters? I done the first one for you. So if you look here, alpha 4 is the indicator is for farm 3. So that's the added effect of being on farm 3 compared to farm 1 for the same seed type. So for example, we look at seed C, and then I can come over here and I could say, well, farm 1 compared to farm 3, the added effect is -2. So anytime for the same seed type, if I'm comparing farm 1 to farm 3, I'm going to get -2. And you can see that for seed A and seed B. So that's what that is. So see if you can figure out what these other alphas are.